We're going to spend some time talking about the number of solutions in a system of linear equations in two variables. And the reason why we're talking about two variables is we're talking about mostly x and y. There are linear equations in more than two variables, but our focus will be on just two variables. So we're going to look at how to write an equation in slope-intercept form, and then we'll spend some time talking about the conditions for the number of solutions of a linear system in two variables, and then we'll talk about the steps on how to get there, and then we'll do a few examples together to just put it together. So how do we write an equation in slope-intercept form? This is a review for most of you that are most probably in Algebra 1 8th grade, but this is a very important topic, so I want to make sure we go through a review. The slope-intercept form is written in the form y equal to mx plus b. You can also look at it as solving the equation for y, or you're solving a literal equation for y. So either one of these, it depends on how you look at it. There's also another way of saying that. You can say using set y as the subject of the formula. So these are different ways of expressing exactly the same thing. So we have an equation here, 2x plus 3y equal to 11. We want to express this in slope-intercept form. So what we're going to do here, so we have 2x plus 3y equal to 11. So we want to make sure that we isolate y. That's the main goal whenever you're trying to write an equation or express an equation in slope-intercept form. So the first thing we're going to do is subtract 2x from both sides. And so that's going to give us 3y equal to negative 2x plus 11. Remember that this is the format that we're using. That's why I have the x coming first. And then we divide by 3. When we divide by 3 to isolate y, we're actually dividing every term on the right-hand side by 3 as well. So y is going to be equal to negative 2 over 3x plus 11 over 3. So this is what we mean when we write this in slope-intercept form. This right here is your slope. This is your intercept. Now, the conditions for the number of solutions of a linear system of equations. So you have three different conditions, or you have three different types of number of solutions. You have one solution, no solution, or infinitely many solutions. For the ones that have one solution, the equations must have different slopes for you to have one solution. When you have no solution, they must have the same slope but different intercept, which simply means that they are parallel lines. And you can see for a linear system to have equations, they must have a common point of intersection. So that's why when the lines are parallel, you have no solution. And then here, this is going to be infinitely many solutions, which means that the equations have the same slope and intercept. So now let's talk about how do we go about trying to figure out the number of solutions in a system of equations. Simply, the first thing you're going to do is to rewrite each of the equations in slope-intercept form. And once you're done doing that, you will then go ahead and compare the slopes. If the slopes are different, the system has only one solution, as we discussed earlier. If the slopes are the same but the intercepts are different, then we have no solution because the lines are parallel. And if the slopes and intercepts are the same, there are infinitely many solutions for the system because every point on both equations is a point of intersection. So that's why you have infinitely many solutions. So let's apply this to some examples. So we have 2x plus y equal to 3, y equal to 3x minus 1. So let's start off with the first one, 2x plus y equal to 3. I'm going to go ahead and write this in slope-intercept form. So I'm going to subtract 2x from both sides. And then I have y equal to negative 2x plus 3. And the second equation is y equal to 3x minus 1. So we can see here that slopes are different. So because the slopes are different, we have one solution. We have one solution in this case. Let's go to another example. Find the number of solutions of the system below. So let's go ahead and we're going to write out the first equation. So 4x minus 2y equal to 11. So we're going to rewrite this in slope-intercept form. So we're going to go ahead and take away 4x from both sides. We subtract 4x from both sides. We have negative 2y equal to negative 4x plus 11. And now we're going to divide everything by negative 2. We divide everything by negative 2. And then we have y equal to 2x minus 11 over 2. And then the second equation is y equal to 2x plus 5. So you can see here we have same slope, different intercept. We have different intercepts. So therefore, we're going to have no solution. No solution. And then the final example. This example is very interesting because this is one of the type of examples you will see on an SAT, ACT, or any of those standardized types of tests that require you to do a lot more mental digging. So it's asking if the system of equations has no solutions, what is the value of B? So what we're going to do first is write each of them in slope-intercept form. So let's go with this. 7x minus 2y equal to 10. So we're going to subtract 7x from both sides. So we have minus 2y or negative 2y equal to negative 7x plus 10. And then we divide everything by negative 2. And so therefore, y equal to 7 over 2x minus 5. The second equation we have bx plus 5y equal to 21. So we're going to subtract bx from both sides. So 5y equal to negative bx plus 21. And then we're going to divide everything by 5. And then we have y equal to negative b over 5x plus 21 over 5. So what we're going to be looking at for here is we already told that there are no solutions. So let's look at the intercept. The intercepts are different, so that means the slopes are going to have to be the same. So therefore, 7 over 2 equal to negative b over 5. So we're going to just do a cross product here. So we have negative b multiplied by 2 equal to 7 multiplied by 5. So we divide everything by negative 2, so we can get b. Divide this by negative 2 as well. So we have b equal to negative 35 over 2. Whenever you're dealing with algebra, you don't necessarily have to put it in a mixed fraction state or a mixed number state. This is perfectly fine. If you want to go ahead and do that, it's going to be the same as negative 17 and a half.